model is a transistor analytical model which describes the operating stages of a transistor. The operating stages of a transistor. This model, operating stages of a transistor. This model is useful. This model is useful to obtain the information about the DC characteristics curve of a transistor. DC characteristics curve of a transistor. Full stop. The transistor operates in active region. The transistor operates in active region when emitter junction is forward bias, and the collector base junction is reverse bias. Full stop. Next line. The behavior reverse bias. Full stop. Next slide. The behavior of a transistor. The behavior of a transistor is generalized by Ebers-Moll model. By taking the inverted mode, inverted mode of operation of the transistor into account. Next slide. Title: inverted mode. In inverted mode, semicolon, comma, next line. In inverted mode, semicolon, comma, next line. Emitter, collector are interchanged. Emitter and collector are interchanged. Comma, where base current return to collector, not to emitter. So, listen, here we are going to have a discussion on Ebers-Moll model. It is a DC characteristics analysis model which is used to prove emitter and collectors are interchangeable with the same condition. Right? That we are going to prove. Okay? So, what is base? Base is a base and emitter is emitter, collector is a collector. But in Ebers-Moll model, we are going to interchange. Usually here the base will come, we have to put emitter. Usually the arrow mark, right? The arrow mark insists that the conventional current direction and that particular point always shows emitter, but here we interchange emitter into collector. This is the fundamental understanding. First point. What we are going to prove? We are going to prove or validate both forward bias and reverse bias voltage still static across both the junctions. We are going to validate forward and reverse bias are still static, which means no effect, right? That we are going to prove it, right? So take down. In general, in general, in general, the collector current is given by. In general, the collector current is given by. In general, the collector current is given by. Collector current is given by capital IC is equal to capital IC is equal to minus capital IC is equal to minus collector current is equal to alpha n minus alpha n dot IE minus ICO e to the power of VC divided by VT, where VC is the external voltage, VT is the volt equivalent temperature, and I forgot to put eta. Let us assume eta equal to 1. Then e to the power of V divided by eta VT become a very VT now. You got the point? E to the power of VF generally. VF means forward bias voltage, right? So here we call it as a VC. That's it. VT is the volt equivalent temperature. What do you mean by volt equivalent temperature? Because we know now today is the summer, right? The winter we have some other temperature. Got the point? So the room temperature is not constant. With respect to room temperature, there is a induced charge carrier across any semiconductor that will be equivalently represented as a constant. The value is 26 millivolts. Okay, so in general, collector current is equal to alpha n times IE minus ICO e to the power of VC by VT. What is ICO? It is a reverse saturation collector current or reverse leakage current across base and collector. Some be governing. We will recap some of the points, right? So what is this transistor, right? What is this transistor? Emitter, base, collector, right? Emitter, base, collector. So let us say this is NPN transistor. What is NPN? Majority is NPN. In N region, electron is the majority. Here again is electron is majority. What is the role of electron? What is the role of emitter? Emitter has to emit the majority carrier. So majority carrier moving towards the junction. So collector has to collect the majority carrier. So majority carrier moving away from the junction. So here this junction, here we have to apply some potential where it will ripple the majority carrier. Here we have to apply some potential where it will attract some charge carrier, mean electron. Okay, so probably here positive voltage that will make this junction as reverse bias. Probably here the negative voltage that makes this junction forward bias. Got the point? What is forward bias, reverse bias? Both are same, which will try to push the majority carriers from emitter to collector. What is the role of base? Allows the minority carrier. This is what we generally studied. So here in symbol, what does symbol represent? Emitter, collector, base. Okay. So what is alpha? Alpha is equal to IC by IE. Alpha equal to IC by IE. What is beta? Beta is equal to IC divided by IB. Beta equal to IC divided by IB. What is this? VBE. VB is always 0.7. Remember there are three fundamental parameters. Look like a date of birth. Date, month, year. Like alpha is the ratio of collector divided by emitter current. Collector current by emitter current. Beta is the amplification factor. Collector current divided by base current. What is collector current? In terms of milliamps. What is base current? In terms of microamps. Micro to milli amplification. Okay, so alpha, beta, VBE. What is VBE? Barrier potential of PN junction. Okay, these three are the parameters. Now, what is IC? IC is equal to alpha times IE because alpha equal to IC by IE. It is in general IC equal to alpha into IE. But we have included the leakage current into account. So in general, collector current is equal to minus alpha n IE minus ICO, reverse leakage current. What is reverse leakage current? Reverse leakage current is always exponentially diffusing, exponentially varying. Okay, charges are diffused exponentially. That's why it is exponential. With respect to what? applied voltage with respect to what? Boundary condition, volt equivalent temperature of -1. This is called current equation. Okay, generally we call it, right? Now, in general, IC is equal to minus. Why minus? Conventional current direction. This is electron direction. Conventional current direction is opposite to electron. That's why you put minus. Okay, ma? So this is generalized expression for any transistor. If I consider collector current is equal to IE. But what we have done in inverted mode, we have done collector and emitters are interchanged, right? In general, this is. What is in general? In general, IC equal to this. But what we made, we interchange collector and emitter. Now, next line. Next line. Where alpha n, where alpha n, where alpha n, where alpha n is current gain, where alpha n is current gain in normal operation. Alpha n is current gain in normal operation. ICEO, where alpha n, next ICEO or ICO, both are same. I suffix CO, hyphen, is the collector junction reverse saturation current. Collector junction reverse saturation current. Reverse saturation current. Reverse saturation current. ஒரு நிமிஷம் கவனிமா. I current C happened at collector O under open circuit. You got the point? You got the point? So PN junction. What is reverse? Remember, when you have a word, hearing a word called reverse, you know, majority carriers are moving one direction. Minority carrier is always opposite or reverse. Got the point? I would say electron moving this way, like me, right? What happened by vacant place? Moving opposite direction. Okay, wow. So this is the current exactly happened at the collector base junction. Okay, by under open circuit, and that is due to reverse, right? Reverse means minority carrier distribution. Minority carrier distribution like this. So let's say this is P and N. So there are plus here. So all the plus in N region, call it as minority carrier. So minority carrier distribution. Okay, that is why I is the current taken at the collector under open circuit, exponentially varying with respect to what, right? Or you could say. Now next line. In Ebers model, this is in general. This is in general. In Ebers model, this is in general. In Ebers model, the equation can be written as. The equation can be written as. In Ebers model, equation can be written. What we can written? Because we have interchanged collector and emitter. We have interchanged collector and emitter. So this is IC in terms of IE is equal to minus alpha 1. Okay, n represent n type, right? Alpha 1 IC minus IC replaced by IE, alpha n replaced by alpha 1, IE replaced by IC, ICO replaced by IEO, e to the power of Vc divided by Vt minus 1, because exponentially Vc divided by Vt minus 1, where alpha 1 is the inverted common base current, where alpha 1 is the inverted common base current gain, is the inverted common base current gain, and I suffix evo is the I suffix evo is the என்னப்பா சொல்லுங்க என்ன பாருங்க நம்ம என்ன பண்ணிருக்கோம் Eber moll model study பண்றோம் for what to validate forward and reverse bias conditions are static தம்பி நான் material mean terminal interchange பண்ணாலும் base emitter should be forward bias base collector should be reverse bias ஒரு இடத்துல push ஒரு இடத்துல pull எனக்கு ஒரு directionல majority flow அதானே so what we are trying to prove we are trying to validate forward and reverse bias or DC conditions of the transistor should be static that is what we are going to illustrate so what is this current what is this emitter junction that too ICO IEO means it is the emitter junction reverse saturation current right is the emitter junction என்ன எழுதுனீங்க it is the collector junction reverse saturation current here is the emitter junction reverse saturation current reverse saturation current the above parameters next line the above parameters next line the above parameters are related the above parameters are related above parameters are related above parameters are related by the condition alpha n ICO equal to alpha n IEO by the condition alpha 1 alpha n ICO next line for any transistor next line for any transistor for any transistor I suffix evo for any transistor I suffix evo lies in the range I suffix evo lies in the range 0.5 lies in the range 0.5 ICO to ICO lies in the range 0.5 ICO to ICO 0.5 50% to 100%. Next line, take down this diagram. Okay, Liz, take down the diagram. Yes, go ahead with the diagram. So the difference is backside little felt little warm. I mean, you could open the door, that one. So this way look, there's a temperature difference, right? Here it is look cold, or I would say low temperature. If you go there, backside it's too hot. I don't know how the people are sitting there. I think here the benches are wide open. Here also the last bench girls also can occupy. Here look like open window. You have a very nice environment, but there even I couldn't walk and come back. Felt very hot. Boys, you can come here. Okay, that is your choice. Okay, if you really want to enjoy the environment, please go ahead. But here look very cold. Okay, now see the diagram. Take down. Okay, va. Jump. தம்பி ஆக்சுவலா புரியலையா? இங்க நல்லா இருக்கு இடம், உட்கார்ந்தா காத்து ரெண்டு சைடு விண்டோ நல்லா இருக்கு. அங்கேயே அப்படி டம்ப் பண்ணி உட்கார்ந்துட்டு இருக்கேன் கடைசியில. ஓகே ஓகே, டோன்ட் டிஸ்கஸ். வரல வாப்பா, நல்லா இருக்குங்க வா. இந்த ரெண்டாவது பெஞ்ச். ஓகே, listen. So the Ebers model, listen. Yeah, by way it look back to back connected transistor. My dear students, listen. What is this? A Ebers model for validation of, it is a Ebers model for validation of forward and reverse bias of any transistor. Okay, so listen, this is a simple Ebers model. The transistor look like this, right? There are three regions, right? Look like this, N, P, N. Okay, look like this, and this is not equivalently correct if I replace back to back connected transistor. Listen, transistor is a three layer, three terminal, two junction device where it has three region, N, P, N, and This is not equivalent to back-to-back connected diode. Why? I'll tell you answer. If you know the answer, please let me know. I'll repeat my sentence. NPN is not equal to back to back. This is NPN. Okay, it is not equivalent to back to back connected diode. At the end of this, I'll tell you the answer. If anybody knows, please. If anybody knows, just proceed. I'll give some slot of time. If not, listen. The last bench, center, Andrew. Please stand up. Okay. Now listen. So I am dealing with the Ebers moll model where it has three terminal emitter, collector, base. What is the pre-assumption or pre-request for this particular analysis? We like to understand that we have to ensure that collector emitters are interchanged. That you have to keep it in your mind, right? That we have to keep it in our mind, right? So emitter, collector, base. Okay. Now you see that it is a it is PNP, right? So PNP transistor. You got the point? It is a PNP transistor. So this P is connected to emitter. This side P is connected to collector, and in between that we have taken base. Again, I am ensuring that this is not back-to-back connected diode. Another. Okay, it is not back-to-back connected diode. Listen, don't talk. You see here, there are 2 ohms, right? One is this represents the equivalent current source, dependent equivalent current source by minority charge. I'll tell you, this is a PN, right? This is a P and N, look like a PN junction diode. Okay, it has 2 paths. It has 2 paths. One represents the current direction, look like a diode symbol. Okay, so PN, one is look like a diode symbol where it carries the current I dash, okay, and minus ICEO is the leakage current offered by the diode. Leakage current offered by the diode. And what is the parallel line? You see that this goes this way, this way, this way, this way. The direction is like this, and like this. It is look like a circulation current. So IC is equal to alpha times IE minus ICO e to the power of VC by VT minus 1. Okay. So this supports the leakage current, and this is the gain of the collector base. You got the point? So this is equivalently represent leakage current offered at the collector junction, collector base junction. Again, this is leakage current. This is a reverse leakage current offered in the emitter base junction. And what is this? This is totally a gain by the particular region, P and N, right? So this look like this. So this look like anti-clockwise. This look like clockwise. Again, I am saying that the back-to-back diode concept is completely different, and transistor is completely different. What is transistor? Transfer the signal. For what? Amplification. For what? Why we built a transistor? Transistor made for amplification. Let us say if I connect a 2 diodes back to back in the laboratory, will I get amplification? No. Why? Because transistor has less recombination. I would say the 100 electron may start from emitter, 99 have reached collector, only 1% retain in the base as a recombination. But back-to-back connected diode, back-to-back silicon, but this is conductor. What about conductor? Recombination is 100%. Let us say back-to-back diode cannot be a transistor. Why? Let us say this is emitter, collector, base. Let us assume back-to-back connected diode. If 100 electron may start and 100 electron may recombine sophisticatedly recombined, or it's stored at the base because the base is conductor. Conductors are rich in electron. Conductors are rich in charge. Even 1,000 electron might start. It will consume. Even 1 lakh electron might start from emitter. It will consume. Look like a Bermuda triangle. It consume it. That's it. No charge will remain, or no charge will return to collector. That is the biggest drawback. So no back-to-back diode never ever replace transistor. Whereas what is transistor? It has recombination. What happened? 100 electron may start, 99 have reached, and one got base. Which means if I connect a 1% as input, I could have a amplification factor of 99 times. You got the point? What is transistor? Transferring signal from one port to another port. What is base current? Base current is equal to 1. What is collector current? It is 99 times IB. If this is IB, then what is the 99 times? What is this? Beta. What is that? Amplification factor. So why amplification factor of the transistor is very high? Because recombination is almost 1%. Why back-to-back connected diode not become a transistor? It is not a like a transistor, or it fails. Why it fails to amplify the signal? Because recombination is 100%. I would say no charge will escape from base, because base is made up of conductor. Conductors are rich in charge. Got the point? Rich in charge. Got the point what I'm trying to say? When a semiconductor, lightly doped, thin region, that is base. So it never ever take more than 1% recombination. Remaining 99 will safely reach to border. Got the point? That is the advantage. So now come to the Ebers-Moll model. You got the point? So collector, base, emitter. What is this? Gain of the emitter junction. What is this? Gain of the collector junction. What is this? Reverse leakage current offered at the emitter junction. What is this? Reverse leakage current offered by the emitter junction. What we are studying? BJT. What is BJT? Bi. Bi means two. Majority and minority. So the current conduction is due to both majority and minority. What is transistor? Transferring signal from one port into another port. What is BJT? Bipolar transistor. So the current conduction because of bipolarity. What is bipolarity? Minus and plus. What is minus? Electron. What is plus? Hole. Very good. So the current conduction is due to both majority and minority. That's why it is a bipolar. Okay, bi. That's why we are considering. You could ask me, sir, gain mattu podume, sir. Why you are worrying about leakage current? Because I am dealing bipolar. I am dealing Bi, 2, right? What is Bi? Bi means 2. What is 2? Electron and hole. That is the biggest problem in the BJT. Because BJT has junction. That is another problem. Okay, wow. Okay, we'll see in the JFET. Okay, so this is the explanation part about this particular diagram, right? Emitter terminal where it injects the electron, IE current. Collector current is also IC. Base, it contributes some base current, and here it is circulate like this, and here it circulates like this. Now we have to apply KCL. What is KCL? Let us say if this is one node, right? There are n connectivity. Let us say like this: 1, 2, 3. What is 3? I3 is equal to I1 plus I2. That is called KCL, Kirchhoff's current law. Sum of the current at any node is equal to 0, or entering current is equal to leaving current. Okay, I1 plus I2 is equal to I3. Next line. Next line. All minority carriers. Yeah, sorry. Wait. Next line. Two ideal diodes. Pass it on. Two ideal diodes. Face other. Two ideal diodes are connected back to back. Two ideal diodes. This is explanation about the figure, right? This is explanation about figure. Two ideal diodes are connected back to back with the saturation current. With the saturation current is minus IEO and minus ICO. Two saturation current minus IEO, ICO. Back to back with the saturation current I minus IEO and ICO. Okay. Okay, back to back. And there are two dependent. There are two dependent current control current source, and there are two dependent current control current source. இங்க பாத்துக்கோ, dependent. ஏன்டா dependent? இங்க பாருங்க, listen all of you. IC current entering, right? Entering எப்படி போகுது? இப்படி போகுது, right? Got the point? So let's say if IC is equal to 0, then I would say it is also equal to 0. Why I'm saying dependent? It depends. It is a source, it is a current source, but depend on IC. Again, it is a current source, depend on IE. Okay, va? There are two dependent current control current source, shunting. Two dependent current control current source, shunting the ideal diodes, shunting ideal diode. Next line. The current source account for minority carrier transport. The current source account for the minority carrier transport across base. Minority carrier transport across base. Next line. An application of Kirchhoff current law, or by applying KCL at the collector node. Apply KCL at collector node. இங்க பாருங்க, diagram பார்த்துட்டே இருங்க. IC is equal to, I am applying KCL here. I am applying KCL at the collector node. Collector current, which is nothing but incoming current, is equal to minus alpha n IE plus I. Alpha n IE plus I. Then what is I? I is the ICEO, right? Alpha n IE plus, Thambi Gavani, this is KCL. I am applying KCL at this node. What is the entering current? IC is equal to sum of the current at the node, right? So IC is equal to minus alpha n listen, IC is the current entering towards the node, am I right? Plus IC equal to current towards the node is equal to, let's say if these two are plus, let's say it's plus, correct? Entering current is equal to leaving current. Ingo current I equal to இப்படி போகுது சொல்லலாம். But what is actual direction equivalent? This direction. So அப்ப நான் என்ன போடலாம் இங்க? Minus. Got the point? ரெண்டு வண்டி வருதுப்பா, ரெண்டு ரோட்ல இருந்து வந்து ஒரு இடத்துல ஜாயின் ஆயிட்டு வெளில போகுது, ரைட்டா? Yes. So collector current is the incoming current and this is outgoing current. Assume this is incoming, but I put minus. I am assuming that outgoing, right? So IC is equal to y minus direction. Okay, IC equal to minus alpha n IE plus I. What is I? I is nothing but yeah, right. ICO e to the power of VC divided by VT minus 1. Theta vandu assume 1, right? Okay, so it's nothing but, so IC is the collector current entering at the node. Okay, wow. Let's say if look like this, if இருந்துச்சுனா I put plus. Listen, when IC current is entering and current leaving, sum of the current 1 plus 1 is equal to 1. But whereas actual diagram, the direction is the direction is opposite. So I put minus. Okay, wa? Where I is the diode current, where I is the diode current, where I is the diode current, full stop. Where I is the diode current, full stop. As I naught is the magnitude of reverse current, as I suffix naught. I suffix naught. Where I naught, where I naught, where I naught is the magnitude of reverse saturation current, then I naught is equal to minus ICEO. Substituting the above equation in equation 3, substitute this one in the equation 3. Equation 3, what we got? Take down. We got what we got. Okay, wow. That's one level. IC is equal to minus alpha n IE plus I naught. Okay, I naught e to the power of Vc by Vt minus 1. Got the point? I naught is equal to minus of this. So this plus become minus. Okay, now come to the point. First ஒரு equation கொடுத்தல்ல அந்த equation எடுத்து படிங்க. In general வந்துருச்சா? Yes, listen. First, what I gave, listen. First ஒரு equation கொடுத்தேன். Okay, IC is equal to minus alpha n IE minus ICO e to the power of Vc by Vt minus 1. Okay, in the ICO one da, right? If I replace, almost both are equal. Hence, this model validate. Hence, this model validate. Hence, this model validate. Hence, this model validate for. Hence, this model validates for forward and reverse bias, for both forward and reverse bias, both forward and reverse bias, static applied voltage across transistor. Next, hybrid, HYBRID, hybrid parameter, hybrid model or hybrid parameter. H parameter. Listen. So we are in the process of important transformation. If you not able to follow this class, I'm sure the analog circuits one in third semester will make you difficult. Right? So I'm going to take you hybrid X parameter model. What is hybrid? So more than one. What do you mean by mono? It's single, right? Hybrid means more than one. First point, how do I understand the transistor? In the science, in science, what is engineering? Application of science. What is science? It is a big branch. It has physics, chemistry, and mathematics. How do I realize? How do I understand? How do I study the science? So through mathematics, right? So I could calculate, I could evaluate, I could manage with the help of mathematics. So what we are studying right now, we are studying start from atom, pure semiconductor, eccentric semiconductor, p-type, n-type, everything by theoretically we have evaluated. But how do I understand? If I really want to understand, I need some calculation. Even if I want to catch the bus in the evening or to Saturday, I need some calculation. I have to start from here at least 2:55. Then only I could able to manage the bus time. Look like that is the mathematical help is always there. So what is H parameter? It is a modeling where it gives the idea about in a single analysis, or I would say it is a static mathematical analysis where you could able to calculate voltage gain, current gain, and so on, input impedance and output impedance. And why we need to calculate? To understand the performance of the circuits. You got the point? So why is mathematics? Okay, there are one more point also. If the device is linear, then paper tharla, yeah, right. If the device is linear, then I could apply linear mathematical. என்ன பண்ண உன்னதான் உண்மையில தான் சாக் பீஸ் போட்டது என்ன பண்ண என்னப்பா சாக் பீஸ். If device is linear, it is advertis if device is linear, it is advisable to apply linear mathematical model. If device is non-linear, then the graphical method is sufficiently good to understand. Now, I would say my transistor is linear, so it is easy for me to apply mathematical model. Okay, how to apply mathematics? Because we know, we know only symbol, right? We know only symbol. What is this? What is this symbol? Nivedita, enna pannittu irukama? I have some good opinion on some people, right? Don't force me to change my mind, right? So it's a symbol. The symbol represents base, emitter, collector, and again I don't want to spend much time on this symbol. This is simple symbol, but what I want to do, I want do analysis. Why I want to do analysis? To know, to understand the performance of the circuit. Why I need it? Because as a designer, I'm going to design a voltage amplifier, I'm going to design a current amplifier, I'm going to design a power amplifier, right? So I want to design a circuit, then I need to know everything. Okay, so the knowing everything by two way. One is mathematical, other one is graphical. What is mathematical? If the system is linear, then I apply mathematics. 1 plus 1 is equal to 2. If system is non-linear, like exponentially, my curve is very like this, my input output are inversely proportional, then I could go for graphical method. Okay, I assume that my transistor is linear, so I apply linear. Okay, so how to convert this? So base emitter, this is simple symbol, right? This is simple symbol. I don't know anything. I don't know even if I want to apply, if I want to calculate, what I want to calculate, LHS is equal to RHS. What I want to know, the value. This side I want some number, that equal to this side I want some number, then only validation. How is this validation done? Mathematically. What is this? Simple symbol. It is a simple symbol. I can't do anything. But what I want to do, H parameter analysis. So how to convert? I'll do the things, right? What is this? Base. What I'm applying? Base is always take the input signal, look like this. This is my input audio voice. Because of this change in small change will be get magnified at this point, call it as a collector current. So small change in voltage have large change in the collector current. Small change in voltage have larger change in collector current. Okay, so because of the collector current, there is a emitter current. So this change will follow the base emitter voltage, look like BE. What is BE? 0.7 volt because it is a silicon made, right? 0.7 volt because it is a silicon made. Okay, I'll tell you my collector current, my 99% variation collector current because of the small change across base emitter voltage. What is base emitter? It is a barrier voltage. Why it is happened? Because of the P region, N region. Because of the P and N region forms the ionic region. That ionic region forms the barrier potential. What is this? N. What is this? P, N. So how could I represent this equivalently? Now I am trying to represent. Now I could represent a battery across base emitter. Battery across base emitter. A battery across base emitter. Now bookல எடுத்து பாருங்க, இந்த எக்ஸ்பிளனேஷன்லாம் இருக்காது. ஆனா PhD முடிச்சிட்டு உட்கார்ந்துட்டு கிளாஸ் கவனிக்கிற மாதிரி பேசிட்டு இருக்கு நிறைய பேர். நான் அவனை மட்டும் சொல்ல விரும்பல. ஓகே, வெரி குட். உன் பேப்பர்ல என்ன எழுதிருக்கேன்னு உனக்கே தெரியும் இல்லையா? நான் வரேன், ரைட்? So this is base emitter barrier potential. So I could represent this as my change in voltage. Now this change in voltage causes some current at the output side. Causes some current at the output side. So the equivalent voltage may convert it into current. So V to I conversion. So I could represent that as my current source. That as my current source. So what is change? Remember ABC, right? You know ABC. ABC. What is A? Alpha. That is equal to IC divided by IE. What is B? B stands for beta. That is equal to collector current divided by base current. What is C? Section C. That is equal to VBE. So basically alpha, beta, VBE is my date of birth. Date, month, year. Alpha, beta, VBE. So I am trying to convert my symbol into equivalent circuit. Then I try to convert that into mathematical model. You got the point? Symbol into equivalency, right? What is this? Barrier potential. What is that? Voltage source. What is that? Voltage source. So V1 is my voltage. Because of that, there is a current. IB is going, right? Because of change in V1, there is a current flowing. It's called IC. What is current gain? What is amplification factor? Beta. What is beta? IC by IB. IC by IB. Then what is IC? IC is equal to beta times beta times IB. Very good. IB equal to IC. Okay, divide by, okay, beta times IB. So because of the current, what is Ohm's law? V equal to IR, right? If I know the current with respect to output impedance, I could able to calculate collector to emitter voltage. So now I know voltage, input voltage, input current, output voltage, output current. Now how to derive X parameter? தம்பி simple இருந்து circuit இருந்து mathematics. இது புரிஞ்சிட்டா நீ third semester attend பண்ண வேண்டியது இல்ல, பட் புரிஞ்சுக்கணும். அதுக்கு தான் கத்திக்கிட்டு இருக்கேன், ஆனா கவனிக்க மாட்டேன். ரைட்டா? கவனி. இப்போ மேத்தமேட்டிக்கல், இது எப்படி மேத்தமேட்டிக்கலா கன்வெர்ட் பண்ணும்? சர்க்யூட் எப்படி மேத்தமேட்டிக்கல் கன்வெர்ட் பண்ணலாமா? இது புரிஞ்சிச்சாப்பா? வாட் இஸ் V? இன்புட் வோல்டேஜ். நான் பேசுற மைக் வீக் voice. Because of the weak change in voltage causes some current. Because of the base causes some collector current. Because of the collector current, there is an emitter voltage. Let it be. So collector current into output, we have V1, V2, I1, I2. This is a mathematical model. Let's say the mathematical model, right? So what is this? What is this? What is this? Transistor. What is this? V1. What is this? I1. What is this? V2. What is this? I2. What is this? What is this? Input port, output port. So now I am going to convert. Now I have taken from the symbol to circuit to raw model into mathematical model. Now the mathematical model, what is this? V1. What is this? I1. What is this? V2. What is this? I2. V1, I1 are input port parameters. V2, I2 are output parameters. I don't want to discuss because I have extracted the exact parameter. Now V1, okay, take down this. So did you got the point? Now I model into matrix, right? So what is V1? Input voltage, my voice, weak voice, where? At mic. V2, loudspeaker. I1, weak signal, microamps. I2, strong current, 99% collector current. So VBE, IB, IC, VCE. இத இப்படி பண்ணிட்டேன். இப்போ now there are 2 points you need to know it. What is open circuit? What is short circuit? இதெல்லாம் நோட் பண்ணிட்டியா? Right? V1 தம்பி இங்க பாருமா, இங்க பாரு, என்ன பாரு எது காப்பி பண்ணு, என்ன பாரு, V1 என்னது? Voice. V1 is voice. Output என்ன? Change in voltage with respect to change in current. V2I, got the point? V2I. So that's why input can be represented by voltage source, output is represented by current source. You got the point? இங்க ஏன் சார் வோல்டேஜ் போட்டீங்க, இங்க கரண்ட போட்டுருக்கலாமே, இங்க வோல்டேஜ் போட்டுருக்கலாமே? மீனிங் இதான், change in voltage because by birth itself barrier potential, PN junction வந்தாலே barrier potential. You got the point? By birth itself makes some barrier. Okay va? So voltage source, the input is nothing but voltage source, output is nothing but current source. So இது equivalent, this is simple equivalent. Equivalently, how can I represent as a transistor? I will draw, don't worry. Up to this, any doubt? V1 is the input, change in input. I2 is the change in del V into del IC. Okay va? That's why V1 is equal to, wait down, V1 is equal to matrix number, simple matrix. V1 is equal to H11 plus H12. I2 is equal to H21 plus 2 2. So V2. Now open circuit, short circuit. That's a very story, and I mattu na vechiko and the condition kaga. Now my two equations. What is the equation? V1 represent voltage source. Kammi gavani. V1 represent voltage source. That is my input. I2 represent output current. That is my current. Okay va? Ipo hybrid nu sonnalla. Hybrid na poly. Hybrid na poly, more than one. Okay va? Ipo na solren yen more than one nu solren. Inga parunga. For example, there are two conditions. Open circuit, short circuit. Na idoda mudikano illa paper kodukka mudiyadhu. Okay va? Continue பண்றேன். ஓகேவா? ஓபன் சர்க்யூட், ஷார்ட் சர்க்யூட். then current becomes 0. எப்பப்பா வீட்ல சப்ளை ஆஃப் ஆகும்? ஃபியூஸ் புடிங்கிட்டா சப்ளை ஆஃப் ஆகுமா? வீட்ல ஃபியூஸ் புடிங்கிட்டா ஓடுமா டிவி? அப்ப அங்க தான் நின்னுட்டு இருக்கும், ஆன் ஆகாது. ஓகேவா? ஓடாது. அப்படி நான் போச்சு. ஃபியூஸ் புடிங்கிட்டா என்ன? ஓபன் சர்க்யூட். what is fuse? weak point in the electrical system. what is fuse? weak point in the electric. அத புடிங்கிட்டா ஓடாது. அப்ப கரண்ட் எப்போ? ஓபன் சர்க்யூட்ல current 0. கரெக்ட்டா? ஓகேவா? அப்பனா நான் ஷார்ட் சர்க்யூட்ல வோல்டேஜ் 0. ஷார்ட் சர்க்யூட்ல வோல்டேஜ் 0. இது ரெண்டும் நான் ஒரு கதை உங்களுக்கு அப்புறம் சொல்றேன். டேம் வச்சு ஒரு கதை சொல்றேன். அது ஞாபகம் வச்சுக்கோங்க. ஓகேவா? ஓபன் சர்க்யூட்னா என்னன்னா இன்ஃபினிட்டி அமௌண்ட் ஆஃப் ரெசிஸ்டன்ஸ். ஓபன் என்ன அர்த்தம்? யோ பாத்தே இல்லையா, எங்க வர சொல்றேன்? ஓபன் சர்க்யூட். ஷார்ட் சர்க்யூட்னா என்ன அர்த்தம்? டைரக்டா 0. திடீர்னு ஃப்ளோர் ஓபன் ஆனா நான் தரையில தான் இருப்பேன். You got the point? Maximum. See, I not equal to 0 na V equal to infinity. When V equal to 0 na I equal to infinity. Okay va? Inga in the equation la in the term 0 aganona V எப்போ 0? V எப்போ? short circuit. Short circuit apply பண்ணா H11 equation 1 la short circuit H11 is equal to V1 divided by I1. V by I என்றது என்ன? ohm. Okay va? Suppose இது 0 எப்போ? ஓபன் சர்க்யூட்ல. அப்பனா என்ன அர்த்தம்? H12 is equal to V1 divided by V2. அப்பனா என்ன அர்த்தம்? வோல்டேஜ் கெயின். ஓகேவா? இது 0 னா என்ன அர்த்தம்? H21 is equal to I2 divided by I1. அப்பனா என்ன அர்த்தம்? AI கரண்ட் கெயின். இது 0 னா என்னது? இது ஓபன் சர்க்யூட். கரண்ட் எப்போ 0? ஓபன் சர்க்யூட். இது ஷார்ட் சர்க்யூட். அப்ப H22 is equal to I2 by V2. What is this? Simon. Mo. Over 3 போட்டா. இங்க பாருங்க. Current gain, voltage gain, input impedance, output conductance. இந்த single analysisல என்ன பண்ணலாம்? Input impedance, voltage gain, current gain, output admittance. அப்ப இதுக்கு பேர் என்ன? இந்த கிளாஸ் நீ கவனிக்கலன்னா I'm sure நீ எங்கனா போய் கத்துக்கலாம், பட் இவ்வளவு தெரிஞ்சுப்பியான்னு தெரியாது. I'm sure you can ask any faculty member. I'm sure, I don't know, they might have idea about the theory part, but deriving like this, it's very difficult, right? Understand? Start from the symbol to equation. எப்ப பாஸ் ஆவ? 6 சப்ஜெக்ட்ல மார்க் வாங்கினதான். அப்ப யார் நல்லா படிக்கலன்னு தெரியும், மார்க் வச்சு தான் சொல்ல முடியும். அப்போ ஒரு சர்க்யூட் டிசைனருக்கு he has to decide எனக்கு எவ்வளவு கெயின் வேணும், வோல்டேஜ் கெயின், எனக்கு எவ்வளவு கரண்ட் கெயின், எவ்வளவு வோல்டேஜ் கெயின், எவ்வளவு இன்புட் இம்பிடன்ஸ், எவ்வளவு அட்மிட்டன்ஸ் பண்ணி ஒரு போர்டு இன்புட் இம்பிடன்ஸ், அவுட்புட் இம்பிடன்ஸ், வோல்டேஜ் கெயின், கரண்ட் கெயினை பத்தி 1 hour பேசலாம். அப்படின்னா என்ன அர்த்தம்? சிங்கிள் அனாலிசிஸ் might explore all. That's why hype. ஓகேவா? ரைட்? நம்ம வேணா ரெஃபர் தம்பி, நான் எதுவும் பேசுறதுக்கு இல்ல, மார்க் எல்லாம் அள்ளி போட்டிருக்கேன். ஆனா எனக்கு எதாவது சொல்றேன், நான் வந்து I want to see few people where they got fail mark. அதாவது ஃபெயில்னா அப்படி இப்படி ஃபெயில்லாம் இல்ல, நான் என்ன சொல்றதுன்னு தெரியலப்பா. நாங்கெல்லாம் 106 காலேஜ் என்ட்ரன்ஸ் அது இதுன்னு எழுதி ஸ்டேட் ரேங்க் வாங்கி உள்ள போகணும், இன்ஜினியரிங் சீட் கிடைக்கிறதுலாம் ரொம்ப கஷ்டம். ஆனா நீ எழுதி இருக்கிற லட்சணத்தை பார்த்தா இதை நான் பெரிய பாவமா நினைக்கிறேன். ஏன்னா நீ மார்க் அதிகமா வாங்கிட்டா பிரச்சனை இல்லை. என்னம்மா என்ன பண்ண, இந்த மார்க் நான் சொல்றேன், என்ட்ரி பண்ண எனக்கு ஒரு ஹெல்ப் பண்றியா? இந்த 2 பென் எடுத்துக்கோ. நான் உங்க மூஞ்ச மட்டும் பாக்கணும், கம்மியா வாங்கணும் மூஞ்ச மட்டும். ஏன்னா யாருன்னு எனக்கு தெரியல, பேர் வேற தெரியல. 127 யாருப்பா? ரெண்டுத்திலுமே போட்டு பாரு. இந்த டோட்டல் இது எவ்வளோ? 23. இது எவ்வளோ? 4. அப்படி போகணும். இல்லை இங்கே எழுதிக்கிறியா? கொஞ்சம் ரொம்ப லேட் ஆகும், டைம் ஆகுது. எங்க எழுதுவேன்? இதுல எழுதுறியா? குட்டியில இல்ல, சும்மா எங்கெல்லாம் நிறைய கேப் இருக்கு. this plus this equal to. ஏமா கொஞ்சம் படிக்கல இல்ல, என்ன சொல்றதுன்னே தெரியலையேம்மா. படிமா, அந்த நல்லா படி, நல்லா வா, சூப்பர். 128 49.5 out of 50. 50 தான், வேற ஒன்றும் இல்லை. நான் அரை மார்க், ஏன் கொஸ்டின் தெரியல. வெரி குட். எக்ஸ் ஏன் சின்ன இருக்கிறேன், ஏன் சின்ன இருக்கிறேன். 130 43. குட். அட மார்க் சொல்லிட்டு போகுது. 147. தம்பி